Okay, transformers. A transformer is a device that's used to increase or decrease the AC voltage, the alternating current voltage. Okay? When you go to travel abroad, you can actually buy transformers to take with you. They're much more expensive than converters and plug adapters, but that's because they do more. Okay? So they're used to increase or decrease voltage. Converters will only decrease, they can't increase. So what is a transformer? Well, it has two coils that are insulated from each other, so like two coils of wire that are insulated from each other, but wrapped around the same iron core. So this is going to be my iron core that I'm drawing here. Okay? And so one coil of wire is wrapped here, and the other coil of wire is wrapped on the other side. Okay, so they're both wrapped around the same iron core. Iron cores, because remember, that'll increase the strength of the magnetic field. One coil, we'll call it this one, is called the primary coil. And you'll never guess what the other one's called. It's called the secondary coil. It is not by accident that I did not put the same number of wrappings here. Okay? If the transformer had the same number of wrappings on either side, then the voltage on both sides would be the same. So if you want to change the voltage, they need to have different numbers of wrappings. Okay? So on the primary side, the primary coil is connected to an AC voltage. Okay, so maybe it's plugged in the wall, whatever, but it has AC voltage. Okay, so now that means there's an AC, or there's an alternating current flowing through this coil on this side, an alternating current that has the voltage of whatever this AC voltage is here. Okay, but if you have an alternating current flowing through this set of coils, and the secondary coil is not that far away, well, the alternating current is going to create a changing magnetic field, right? Because remember, the alternating current is going up, coming down, right? It's a sinusoidal wave. So it has bigger current, smaller current, switches direction. So the field around this current is going to be changing. And this wire is in that changing field. And when you have a wire that's in a changing magnetic field, a current is going to be induced in this wire. Okay, so the primary coil is connected to an AC voltage, and the changing current in the primary coil creates a changing magnetic field, which in turn then will induce a current or induce an EMF, induce both, in the secondary coil. Okay, so the primary coil has an alternating current in it, and that, because of the changing magnetic field, induces an EMF and an induced current in the secondary one. The induced EMF over here in the secondary one is proportional to the primary voltage and to the number of turns or wrappings. So however many times, so sometimes they're called number of turns. They could be called number of coils, number of wrappings. It just means how many times you've wrapped the wire around that iron core. Okay, so what we just said was the induced EMF in the secondary coil is proportional to the primary voltage and is dependent upon the ratio between these wrappings. The equation's really easy. It's V secondary over V primary is going to be equal to N secondary over N primary. Okay? So if the number of turns in the secondary is bigger than the primary, then your voltage in the secondary will be bigger. And when that happens, it's called a step-up transformer. So when NS is greater than NP, and you should be able to see that by the math, right? When NS is bigger than NP, that means VS is going to end up having to be bigger than VP. So when NS is bigger than VP, VS will be larger than VP, and this is a step up transformer, meaning you're taking the voltage and you're upping it. Okay, a step up transformer. And the reverse is true. When NS is smaller than NP, the number of turns, I guess I should have told you that. N is this number of turns, number of wrappings, V are the voltages. So when the number of wrappings in the secondary is less than the number of wrappings in the primary, then the voltage or the induced voltage in the secondary will be less than the induced voltage in the primary. And this, you'll never guess what it's called. This is a, can you guess? Step down transformer. Okay, so it means that you're taking a higher voltage and you're decreasing it. So in your house, remember we talked about the fact that higher voltage is easier to send, and you need some 240s in your house, but then it'll take the 240 line for your other appliances and it'll put it through a transformer that will step it down. Okay, so it's called a step down transformer. So this is almost the whole equation. Almost, because remember V equals IR. Okay, actually, and remember maybe from grade, no, you didn't learn it in grade 12 yet. Power is equal to work over time from grade 11. And we know work is equal to, we know voltage is equal to work over charge. So that means work is equal to QV. So if I fill this in here, QV over delta T, Q over delta T is I. So power is actually equal, when we're talking about electricity, to current times voltage. It's really easy to remember. If you're weak and not feeling great, they hook you up to an IV and they make you more powerful. What this also means is that a watt, which is what power is measured in, is equal to an amp times a volt. Okay? But all of this to say, usually the power doesn't change. If the power doesn't change, it's called an ideal transformer. And ideally, we want the power to not change. So if the power doesn't change, and power is equal to IV, and the voltage goes up, then the current has to go down. Or if the voltage goes down, the current has to go up. So we have another section of our equation here that we can use, and that section is the I's. But the I's are opposite. If they're inversely proportional. So it's going to be the primary on the top and the secondary on the bottom. Okay? And you would get that because in an ideal transformer, the primary power would have to be equal to the secondary power. So I primary, get my things tilted the right way for you, I primary, V primary has to equal I secondary, V secondary. And so if you rearrange this to get V secondary over V primary, divide, you'll end up with I primary over I secondary. Okay? So this is your transformer equation. It's really just ratios. Obviously, you only use 2, depending on what you're given. Okay, so your homework today, which will really be for the day after the test, will be using this. All right? Very good.